So this is the what's Brandon was yesterday's homework hard? Hard? Was it break?
Hard? No.
No. Do you understand it?
Yeah.
Okay. So what I'm gonna do is talk about power series. How do you use power series to represent a function? And so I'm gonna go through one other example that we have covered yesterday.
Student, 1 minute remaining until class.
This sounds long. Okay, I'm recording for Calc BC class, so you guys need to be quiet. Any student come inside? Actually, keep that door open, just so that way they come inside doesn't slam the door. Okay, so if I want to center at x equal to 1, so that means I need to replace, I need to somehow to change this to a over 1 minus r. And the only way that can happen for 1 over x is to make sure that is equal to, and you have to have a center at this one, x equal to 1. That means center is x minus 1. So what I will do is I will change this to 1, and it's gonna be 1 minus of, I'm gonna replace that as negative x plus 1, because this will be same situation as my geometric series. Same situation of my geometric series. Now, when I do that, that 1 over x can change the geometric series, because this one I can rewrite as a factor out of negative sign of x minus 1. So this will be n equal to 0 and infinity, and here it's going to be negative of x minus 1 to the n power. So this becomes one of the things that you supposed have memorized, and you can write it out as much you want. You can say it's okay, yeah, that's 1 minus x minus 1 times plus of x minus 1 squared minus x minus 1 to the third dot 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 dot, and basically this is going to be the general term. Also, you have to worry about the interval convergence. Interval convergence is gonna be this ratio. Now, usually we do like a ratio test, but here it's in the geometric form. I just need to figure out my radius is. So x minus 1 the absolute value is less than 1. So that means x minus 1 less than 1 and less than negative 1. So if I add 1 on both sides, so that'd be 2 less than x less than 0. I don't need to check an endpoint because when r is equal to 1, that is not really defined. So therefore, that's going to be 0 to 2, and I don't need to check endpoints. So we just talk about a power series. Interestingly, that if you really want to find out the power series or representation of natural log of x, you can actually take a shortcut by just integrating both sides, and you can actually do that. You integrate both sides, it should come out exactly the same. So like I say, I'm going to extend to this question. And we already know this is the format here. And I'm going to take this. I'm going to take this, drag it down. Says, hey, that's 1 over x equal to summation of n equal to 0, infinity of negative of x minus 1 to the n power. So I can integrate this. If I integrate this, what am I going to get? Integrate 1 over x, that's equal to what? ln of x. But when you integrate, you are going to get a c. And that's what you're going to get c here. Then also, but if you integrate the 1 over x dx, but now we are integrating the power series. So if I integrate the power series, it's going to change a little bit. So plus integration of this, right? And if I integration of that, it's going to be negative 1 to the n to the x minus 1 to the m plus 1 over m plus 1. So you can actually integrate both sides, and that this will become a representation of the power series for natural log of x. Very useful tool because you can take a derivative of both sides and you can take integration of both sides. It still follow the same conditions, which is super awesome. Okay. Now, and this tool can be used to find out the power series for the arctangent, same way as what you do before. But I'm not going to do that. I'm going to go in to talk about different things. So hopefully everybody understand the situations. One last situation. Actually, I'm going to talk about 2 more situations. How do I find f of x equal to x squared sine of 2x? And how do I find the Maclaurin series? So I'm going to say Mac series. And it's actually easier than it looks. Because you can actually take this and we can say, well, we know this power series. We know this power series. We know this. And we can write it down for you. Sine of x is equal to x minus x cubed over 3 plus x 5 over 5 factorial. They forgot about the factorial. And then we can write down the general term. So sine of x is equal to the summation. Oh, sorry. I'm going to plug in sine of 2x. So sine of 2x, it just means you replace everywhere x. Replace the x with 2x. So if I do that, I will get 2x for the first term minus minus 2 to the third x to the third and over 3 factorial plus 2 to the fifth x to the fifth over 5 factorial. Now obviously I can write that in terms of general form. So sine of 2x, which I'm going to write in power series, which is n equal to 0, infinity, -1 to the n, and 2 to the 2n plus 1 times x to the 2n plus 1 all over 2n plus 1 factorial. So I basically replace, I'm going to say this again, I replace this x with 2x. That means every term where x is, I'm going to replace as 2x. So I'm going to use that to write a power series. Once you write a power series, then you can say, oh, okay, well, can I just multiply x on both sides, x squared on both sides? Because we want a Maclaurin series. This is part is missing. This part is missing here. So I can install it here and just multiply x squared on both sides. So then that's going to be x sine of 2x squared equal to summation of n equal to 0, infinity, -1 to the n, 2 to the 2n plus 1. Nothing is changing except this part is going to adding x squared. So it'll be x to the 2n plus 3 over 2n plus 1. And this becomes a power series of this. Very, very, very interesting. Because now I can find a lot of different function in terms of power series. In terms of power series. I don't know, Brandon, do you understand what I'm saying? I just write, okay, so first of all, I write out sine of x power series. Second of all, since I want to sine of 2x, because the function we want is x squared sine of 2x. So I'm going to replace everywhere x with 2x. And then I write down the general term. And then I want to multiply by x squared on both sides. I just multiply x squared in terms of power series. I'm going to get a new representation. Now, if you want to check if this is true, you can always graph x squared sine of 2x and then graph the summation as well. You should see them matched up very equally. Now, with that being said, I'm going to talk about one last thing. Well, actually, I want you to try in class okay, I want to talk about two more examples today. One right here. So we say we can represent any function now, but just knowing by using those functions, you can change. You can change to a lot of different things. Oops, what happened? When did they go away? Just now?
Yeah.
I unplugged it. I'm an idiot. Okay, so basically you can represent another function. And there's a way to get arctan as well. So if you think about arctan, this is 1 over 1 minus x. you can use the power series, change this x to negative x, and also change the square. Then if you replace that and you integrate both sides, you should be able to get the power series of the arctan, and that will be something that we're gonna do tomorrow. But today, I want to see that show you one more thing here, which is the integration of 0 to 1 e to the negative x squared dx. Let's do it without a thing. Let's do it definite integral. Do we know e to the x? Well, we should know e to the x. E to the x equal to what? If we don't know, we can look it up. Yeah. It's not. Great. Not registering. Try this again. And now I should be able to show. Nathan. Okay, so what we're gonna do is it possible to take an integration of this now? Which is with the help of integrations, with the help with the power series, we can actually go back and look up the power series for e to the x. E to the x equal to 1 plus x squared over 2 factorial. So 1 plus x over 1 factorial plus x2 over 2 factorial plus x3 over 3 factorial. Now that means e to the negative x squared, you're going to replace that with everything here. So you're going to replace that with e to the next x squared. So it's going to be 1. If I replace that, it's going to be negative x squared over 1 factorial plus plus x to the 4 over 2 factorial minus x to the 6 over 3 factorial dot dot dot. Then with that, I can say, okay, well, that just means e to the negative x squared is equal to summation of first term is 1 and n equal to 0, infinity here. The first term is 1. So, and it's positive because it has alternating sign. So this negative, positive, negative. So it has to be negative 1 to the n. Now the x is always even power, so it'll be x to the 2n over n factorial. Now what I can do is I can replace this and I say, oh, okay, well, let's take integral of that. So if I integrate e to the negative x squared, that means I integrate this power series. So I can say, okay, well, that's n equal to 0, infinity, negative 1 to the n. If I integrate x to the 2n, it will be x to the 2n plus 1 over n factorial times 2m plus 1. So we just integrated this. And if it's a definite integral, let's just say if the today is 0 to 1, e to the negative x squared, you're going to plug in the integration of this, which is the plug-in of x minus x minus x to the cube over 3 plus x to the 5 over 5 times 2 factorial minus x to the 7 over 7 times 3 factorial plus x to the 9 over 9 times 4 factorial between 1 to 0. Now you can plug in 1 here. And if you plug in 1 here and you plug in 0, you will get the result. But if you plug in 1, it's going to give you 1 minus 1/3 plus 1/10 minus 1 over 42 plus 1 over 216. Of course, the error is going to be your next term, but this will be a good approximation of the definite integral. Not only you can do indefinite integral, you can do definite integral as well. On a function, normally, I cannot integrate this because U substitution does not work. So, yeah, that'll be all. And today I will not be here, so I'm going out. See you later.